Hey, today we'll be talking about linked lists. Just as how you know what lists are, list contains a bunch of things or a bunch of elements grouped together. In a scientific sense, the list we're talking about is similar, a group of objects that may or may not be related to each other. But linked lists are somewhat different, because unlike normal lists, linked lists have their objects with a relationship with their adjacent elements. We'll go over that in a second. Next is we need to know what an array is. An array is also like a list. It contains objects, but what's different is that these objects have something called an index. An index is a number given to an item based on its place in the array, and it starts from 0. So the first item in your array is at index 0, and the next would be at index 1, and so on and so forth. But here are their key differences that give them each their own advantages and disadvantages. Unlike arrays and lists that has an index, which make it easier to get an element, for linked lists they don't have an index. Instead, each element or node has a relation or a link to the next element. That's what allows you to travel between the linked lists. So arrays are ordered, linked lists are not. Arrays have an index and linked list does not. Another would be how you get or access to an item in the array or linked list. With arrays, you only need to know the index or the number of item you want to get, remove, or update. While for linked lists, since you don't have a shortcut to get a specific item, you need to travel through the elements of the list, from the first to the next and so on. And unlike arrays, linked list has an indicator for the front and in the back, the head node and the back node. There are many types of linked lists, and the first one we'll discuss is singly linked lists. So linked lists are a group of objects linked together. Think of it as similar to a chain, with each chain link linked to one another. For singly linked lists, the chain link has a link only to the next link or its successor node, meaning it doesn't have a link to its previous node, unlike doubly linked lists. For doubly linked lists, unlike singly linked lists which only has access to its next node, DLL or doubly linked list, but DLL for short, has access to both its previous and next nodes. This allows for easier traversal back and forth for us to delete or add an item much easier than in a singly linked list. Circular linked list. From the name itself, this type of linked list runs in a circle. Its characteristic rather runs in a circle, meaning it doesn't have an end, and any point in the list can be your starting point, since the last node has a link with the first node of the list, giving it its circular direction or characteristic. Unrolled linked lists are a bit more complex, in a sense that each node contains multiple elements, and these elements are stored in a link as well, more precisely, a circular linked list. So in an unrolled linked list, it stores multiple elements in one node called a block, and these multiple elements stored in each block is stored in a circular array. Skip lists are also a bit more complex. The main purpose of this type of linked list is so that we can skip from a node to another node and farther. No traveling necessary going from the next to the next to the next until we reach the node that we desire. Remember that unlike in an array where we can directly access an item, no matter where by using its index, for a linked list we don't have that. That's why the skip list is made, for easy access to any place in the linked list. Skip list isn't a simple link list as it has multiple layers. The first layer, which consists of a normal linked list, while the second and the subsequent layers are also linked lists, but the nodes that point skip to the elements from the first layer. Linked list has many applications. It can be used to implement queues and stacks, which we'll talk about in the next lesson, and linked list can also be likened to a train, where each vehicle is connected to one another, forming the train. It can also be likened to browser tabs, wherein each tab is a node with a relation to all the other tabs. For example, would be when you close one, you get back to the last tab that you visited.